Okay, welcome back. So we are going to be fine-tuning spanning tree protocol. So things we are going to do in this video, very simple. How do we even know? Because you can see here that I think that the election already is concluded, and you could see that switch 1 seems to be the master because 2 of his ports, you can see port 10 as well as port 11. Just hold on, let me pick up my pen. So port 11 is below here, right? Port 10 is above it. So this is port 10 and this is port 11, right? And both of these ports on switch 1 are all green, but that's not the case with switch 2. So down here on switch 2, we could see port 10 is green, but port 11 below here is amber. It will never turn to green. So it means that this second link here is blocked. By who? By spanning tree protocol. Why is it blocked? So that if somebody here needs to reach somebody here, the data will not be sent twice using the first cable and the second cable. Because if it's sent twice, we're going to have loop. And loop is not good for our network because it slows down everything. Okay, so spanning tree is ensuring that loop is not occurring by blocking one of this link, and that's why it will never turn to green. Alright, so let's dive into the switch now. I want to log into the switch and we are going to do show spanning tree. First thing we need to do is to know which of these two switches is elected as the master. Okay, so that is the first task. We want to find out which switch is the elected switch, and secondly, we could modify the outcome of the election, right, and make the other switch to be the master just for the fun of it. And we could also change the flavor of spanning tree, right? So we want to change the spanning tree flavor. Maybe I believe that is common spanning tree that is running here, which is the one that takes up to 50 seconds to detect a link failure. So probably we'll change it to rapid RSTP, which takes just 5 seconds to detect a link failure. So this will be the objective. Let's get to find out which of these two switches is the Oga or the master switch, because the election has been concluded. Alright, I'm going to get into switch 1. So just click on the switch and let me expand this guy so that we'll be able to see all the outputs of the show commands that we're about to do. Alright, so I think it's okay like this. So we are on switch 1 actually, and we just do enable and we do show spanning -3 and hit the enter key, and here you could see that let me scroll up to the beginning of the show command. Okay, here is the beginning of the show command. So you could see the command we just typed in. Show is abbreviated as SH. If you like, and complete it by typing OW to it. That will be show spanning -3, and you could see that the spanning tree we are running is IEEE. Okay, so this tells us that this is common spanning tree, which is the 802 IEEE 802.1D spanning tree. This is the one that takes up to 50 seconds to detect a link failure before it switches to the backup link. Alright, so we shall be changing this based on the objective of this class. But what we actually want to find out based on what we want to achieve here is, number 1, which of these two switches is the master or the Oga, or what they call root bridge. Now you could see that in this switch is telling us that this bridge is the root. So in other words, it's saying this bridge is the master, is the Oga switch on the network. Alright, so we get to see this by going to each of the switches we have and do show spanning tree. So when we do show spanning tree, we are going to get 2 information. 1, we know the type of spanning tree that is running. 2, we know whether the switch is a master switch or not. Okay, so keep this information in your memory the spanning tree protocol here is the RSTP common spanning tree, and this switch 1 is the other. Now let's scroll down on this show command, and you're going to see that this switch 1, let me bring up this, sorry, where is this guy? So you could see that this switch 1 here is using port 10 and port 11. So you could see it here, F0/10 and F0/11, and you could see that both ports are forwarding, right? FWD, that means that they're allowing traffic to pass through them. And yeah, so that is what information I want to pick from this switch. And you also notice the MAC address of this switch, that the MAC address of this switch is 0002. So I believe that the priority of these two switches should be at the default, because we have not made any changes on the priority. So you could see the priority is 32,768, which I mentioned earlier is the default. And so if they happen to be the same thing on the two switches, it means that the switches will resort to using MAC address. And for this switch to have been elected, it means that the MAC address we are seeing here is lower compared to the MAC address of the second switch. So let's go to the second switch. That is switch 2. So once again, let's expand this guy. Alright, so here we are going to do that same command, show spanning tree. Let me just expand this guy so that we'll see a couple of these commands. So you can see we are on switch 2, right? At the left hand side here you see SW2. So we'll do enable and we do show. If you like, can complete the spelling of show, or you just abbreviate it as SH. Spanning tree. Hit enter key, and you could see why the second port on switch 2 is amber. Switch 2 is also using port 10 and port 11 to connect to switch 1, just as you can see here. So it uses port 10 and 11, but one of the ports is in amber. It never turned to green. And why is that? Is because that port, that is actually port 11, is being seen as a backup, link to switch 1, right? Alternate. The alternate here, ALTN, meaning a backup. And because it's a backup, is blocked. Who blocked it? Spanning tree protocol. So the only port allowed to use to send out anything on switch 2 is port 10. So you can see port 10 is forwarding, and it's telling us that that port 10, the role of port 10 is what? Routes. Meaning that that port 10 is connecting us to a root bridge or the master switch. Okay, so and let's look at the MAC address of this switch. You could see that when we come up here to where we did show spanning tree, you also see that the spanning tree enabled protocol is IEEE, which means that this guy is also running common spanning tree, which takes up to 50 seconds to detect a link failure. And other things we need to pull out here, we did not see that message that says this bridge is the root. We did see that message when we were on switch 1. Let me quickly get to switch 1, and you could see a message here that says this bridge is the root, right? And let me minimize switch 1 and go back to switch 2. So on switch 2, there is no message like that, which means that this guy is not the master. Rather, switch 1 is the master switch. Okay, so what is this guy's MAC address? Let us look at the MAC address of this guy. So the MAC address is found under bridge ID, and here it tells us that the MAC address is 0090. Let's just stop here. What is the MAC address of switch 1? Well, if you go back to switch 1 and go under bridge ID, you see that MAC address of switch 1 is 0009. Okay, now if we compare 0002 rather, not 0009. So 0002, compare it with switch 2 MAC address, which is 0090. So you see that the third octet here, the third number rather is 9, while the third number on switch 2 is 0. So of course, if you compare 0 and 9, you already know the answer. So you could see that the third number here is 9, and 9 obviously is higher than 0, and so switch 1 MAC address is lower than switch 2 MAC address, and that's why switch 1 was elected as the master switch. I think that is very straightforward. Now let us look at the other thing we want to do. We want to modify this election. So let's say this switch 1 that is elected, we don't like it. Maybe it happens to be the oldest switch we have on the network. Maybe this switch 2 is the newer switch, right? It's logical. The oldest switch will have the lowest MAC address. And so we want our latest switch to be the master, because it probably will have latest switching technologies. So how do we make this switch 2 to become the master, where we now see the message, this bridge is the root, and this guy will be the one to shut down one of its ports. So let's see how we can modify the outcome of the election. So we'll get into the switch 2, because it's switch 2 that we want to become the master now. So go to switch 2 and just scroll down, do conf t, and here we do spanning. Let me keep my pen. So we do spanning tree, VLAN. Now here is tricky, because we have how many VLANs? You know, there is a VLAN 1, which is the default VLAN. We also have VLAN 2, 3, 4, and 5. So we want to factor all these VLANs. So say spanning tree VLAN 1 to 5. So the 1 is the default, while 2 to 5 are the ones we created. So spanning tree VLAN 1 to 5, roots, primary. That's the simple command. Alright, so with this command we made, we are done. So what is the outcome? The outcome is that this guy is going to become the master switch on the network. So you could see that this one is turning to amber now. Before, both sides were forwarding, but it's going to change. Equation is going to change now, where both sides of this switch 2 will now be green, as compared to how it was before, where one is green and one is amber, which means the one on amber is blocked by a spanning tree. So the election has been reversed. And if we go back to this same switch, we just did the command spanning tree VLAN 1 to 5, root, primary. If we do show spanning tree here, show spanning tree, enter, you could see we now have this bridge is the root. And because of that command will run, it has cut this switch priority to 24,578, which is now lower than the default. The default is what? 32,768. And that was why this guy became the master. Okay, so as a result of the command that we issued here earlier, once again, see the command. I have to scroll up and see the command here, spanning tree VLAN 1 to 5, root, primary. Okay, once that command is done, you end and then save the configuration, show spanning tree. You see that we have overthrown the switch 1. So switch 1 is no longer the master. So if you go to switch 1 and do show spanning tree, you see that switch 1 will be the one blocking one of its ports. No longer switch 2 blocking one of its ports. Okay, so we've achieved that objective of changing the outcome of the election. Let's just confirm on switch 1, show spanning tree. Of course, this guy, port 11, is now on block mode. Okay, so mission accomplished. The last thing we have to do is to change the mode of the spanning tree from the IEEE, which is common spanning tree, to RSTP, which is rapid spanning tree. So that just 5 seconds is what it will take for switches here to detect that, oh, the primary link is down. Let's now switch to the backup link and then remove the blocking on that link. Okay, so how do we do that? Let's start from switch 1. So you could see when you do show spanning tree, it tells us that the spanning tree enabled protocol is IEEE. So let's change that. Here, go to conft on switch 1, simple command, spanning tree mode rapid. It's as simple as that. And end and save. So once again, do show spanning tree. Straightforward. So the last time out we did show spanning tree, it was showing IEEE here, but you can see now we have changed it from IEEE to what? RSTP, which is rapid spanning tree. Okay, so let's do the change also on switch 2. So go to switch 2. You see that switch 2 is still showing spanning tree enable protocol IEEE, which is common spanning tree. Let's change that guy. Go to conft. Simply put spanning tree mode rapid. Okay, so it's going to change from this IEEE to rapid. So you could see here before I hit the enter key is on IEEE. So let's hit enter and do show spanning tree once again, and you should see that it has changed. End and save and show spanning tree, and you could see that it has changed from IEEE to rapid spanning tree or RSTP. So we have actually accomplished the task of fine-tuning the spanning tree in this video. So we've been able to find which of the switches is elected as the root bridge or the master switch by doing show spanning tree on both switches. We've been able to modify the outcome of the election by making switch 2 the master switch on the network or the root bridge and taking that responsibility away from switch 1. We've also been able to change the mode of spanning tree from common spanning tree, which is IEEE 802.1d, to rapid spanning tree, which is IEEE 802.1w. That's how far we can go on this video. Thank you so very much for watching, and see you in the next video.